All right, everyone. Welcome to the other conceptual model, the OSI model or Open System Interconnection model. All right, it's a 7-layer model, which we'll discuss. But first, let's just look at a history. Not that they're going to actually ask you any history questions on the certification exam. Know that it began in the 1970s. It was actually the ISO, the International Organization for Standardization. So backwards, right? OSI, ISO. All right, but it wasn't published until 1984 that it was adapted. Again, it was the concept of 7 layers, and Mr. Charles Bachman was the one that actually created it. Information to know, you put it somewhere in there. You remember at a cocktail party, you make yourself look smart. That's about it. It's not going to be asked in the certification. Okay. But please don't talk about OSI model in a cocktail party, okay? Unless we're all IT guys. Either way, here is your OSI model. Just quick, 7 layers. All people seem to need data processing or Domino's pizza, as I like to call it. And these are your PDUs, which we'll discuss later on. Your protocol data units, all right? Data, segments, packets, frames, and bits, which I call don't, right? For the D, don't stop pouring free beer. Again, we'll go over that later on. But this is your OSI model. We'll be diving somewhat, not deep, because we're not going to get too deep. Basically, this is as deep as probably going to get. But again, we want to be prepared for anything they throw at us. And obviously, once we get into the field, we want to know what we're talking about when it comes to layer 2, especially troubleshooting, because you do have a lot of layer 2 troubleshooting and layer 3 troubleshooting when we talk about the network layer or data link layer, and sometimes the physical layer because our cables go back. All right. With that said, there's your OSI model right here. I will see everyone in the next one. All right, welcome back, everyone. Now we're going to do the OSI versus the TCPIP model. We've briefly touched upon this, but you're going to go look at it in a different perspective. Okay. Here you can see it in a much bigger scale. All right. We have our 7 layers, right? The layers 7 through 1. Here are the names of the layer, the application, presentation, session, transport, network, data link, and physical, right? We have our own mnemonic devices that we're going to use, whether it be all people seems to need data processing, right? Data processing or Domino's Pizza or whatever you can think of. But use it in your mind so you know the order. Write it down before you take your test. That way you don't need to memorize anything. Just whatever's in here, you put it on that laminate that you go before you take your certification. You write it all down with what they give you. Don't take anything with you. All right. And we have here our TCPIP, and this is the new TCPIP model with 5 layers, as opposed to the older one, which was only 4 layers. Okay. But you can see that the mapping of these, that's why it's color coded, because I have a, I want to make sure that, I'm not too good in aligning, but it's color coded. The upper 3 layers of the OSI model are going to be mapped over to the application layer of the TCPIP model. What does that mean to you? That means that whatever happens here, okay, in the OSI model, whichever application, format, dialog control, all that is going on in the TCPIP model at the application layer. That's what that means, okay? You have your segment on the OSI will transfer over to the transport on the TCP/IP, right? It maps over directly. So anything that in the OSI model, the TCP, the windowing, the sequencing, the congestion avoidance, all that happens here as well, okay? Here I put PDUs, all right, and you can see that each PDU is, well, for the upper 3 layers is data. So for the 4th layer or the transport layer is segment. It'll be the same thing here. So segmentation occurs at the transport layer. All right. Now we go to layer 3, which is the network layer of the OSI. So it maps over directly to the network or internet of the TCP/IP model. Then now the data link and physical will map over to the data link and physical, all right, of the TCPIP model. So that's how they map over. That's the kind of questions that you need to understand that they're going to be asking you. When you're comparing these two different models, and keep this in mind, all right, because I know some of you are like asphyxiated or, oh my God, obsessed with the OSI model. When you take the test and then you go to your field, if you want to create a new layer, if you want to develop an existing layer and make it better, then hey, by all means, knock your socks off. If you want to know every last little detail of each little layer, you go for it. You do that. That's great. Education is wonderful. All right. But for this certification, what you see and what I tell you, that's what you need to memorize. They're not going to drill you to that granular level. They are not. Okay. So basically, it's just memorizing the layers, what works on the layers, and of course, comparing the TCPIP model, the new one or the old one, all right, to the OSI. What layer maps over to this layer on the OSI or the TCPIP? That's all it is. Okay, that's all it is. What, like you see here, DNS works at the application layer. I made that analogy already. If you're getting some sort of congestion, well, it happens in the transport layer. Transport layer takes care of that. If you're having issues with routing, right, get to where you need to go, well, then that's an IP thing. You can see ICMP works right there at layer 3. So these are the things that you need to pay attention to, because that's the most common things that you'll run into, and questions you'll run into, and things you're going to run into in the real world anyway. But I digress. This is a comparison of your OSI model mapped over, it's color coded, so match up the colors, all right, to the TCPIP model. That is what you need to be concerned with. That is what you're going to be tested on. That is what you need to know. I'll see you in the next one. All right, welcome back, everyone. Yes, once again, the OSI. But we just now, let's start explaining a little bit more. All right. We already know the layers, we know the names of the layers, and we know what's working on these layers. Okay, I even give you some extra stuff on the other slide of what's working. All right, but this is basically it. This is the most common thing. All right. The PDUs. You got to know your PDUs. Your PDUs are your protocol data units. These are the ones. This is the process of encapsulation. And it sounds like a test question to me. I don't know. If I would be still teaching out of college, I will make it a test question. I'll put it to you that way. All right. What is the process of encapsulation? And you'll have access to this document. So I think it's down here. It sure is. Okay. What is the process of encapsulation? Data, segments, packets, frames, and bits. Encapsulation, right? Encapsulation happens going from layer 7 all the way down to layer 1. Once it gets to the other side, it de-encapsulates. Meaning just like a letter, right? In all the books, in all the networking books, they use the letter example where you write a letter in a certain format, you fold it, you put it in an envelope, you're not encapsulating it. Then you're putting more information, where it's coming from, where it's going to, source and destination addresses, and then the type of media that you're going to send it out on. It's going to be a post office, there's going to be a boat, there's going to be an airplane. So all these different things, all right? So this is what this process of the layered model explains to us, this concept, okay? So these PDUs, you need to know, they speak to their peer layers on the other side, not through the air, okay? Not through the air like I thought when I was going through school, because nobody explained it to me. They just said, hey, it's the peer, the segment PDU will talk to its peer layer on the other side. So I'm like, me being me, I'm like, really? How does that work? Is it just through the air? They just talk to each other? Or, logically, it has to go through the cable or wireless or whatever. But nobody really explains to me. And all it is, it's a number. So a mathematical calculation that they use. When they get to the other side, they run this thing, and they're supposed to come up with the same information. That's where the sequencing comes in, right? Everything comes in the same order. All right, the window size, that's why we get acknowledgments. That, hey, wait a minute, I'm missing something. Resend it again. So it's important that you know that. So PDUs talk to their peer layers. so they know when they get to the other side to de-encapsulate, to put everything in the correct order. All right, and you see down here I have a definition for it. Is it down or up? It's up. Okay, is a method of designing modular communication protocols in a logically separated function in the networks are abstracted from their underlying structures by inclusion or information hiding within a higher level object. That's all it is. And here you see the encapsulation order. That's all it is. That's all it is. So as it encapsulated into this one big envelope, it then has to de-encapsulate it on the other side. All right. So the upper three layers, they're all the same, one big chunk of data. Not until they get to the layer 4 that actually starts segmenting and saying, hey, okay, what protocol we're going to use? More than likely, depending obviously on what we're doing, it's going to use mainly TCP. And that's just where we get our acknowledgement, because it's a connection-oriented protocol, where UDP is a connectionless, means UDP just sends it. If it gets there, it gets there. That has no error detection or flow control, nothing. Just, here you go. All right, so, but TCP does. It has the acknowledgement, the NAC, the windowing, the sequencing, all these different things. And even for streaming, you have the SCTP. So all these things happen at this particular layer. Layer 3, again, we have IP. These are connectionless. That's why we have TCPIP. So the IP is the connectionless protocol. IP, IPX, which we really don't use. Here we have now our routing protocols and routed, because routed protocol will be IP. That's the IP address that sits, whereas version 4 or version 6, that's what sits on the interface. That's what sits on the NIC card, all right, of any node on your network. And then the routing protocol is the one that chooses the path selection. So this is what's going on at this particular layer. It's putting that information onto as it goes down. Frames, well, we're dealing now with what? MAC addresses. We're dealing with switches. Bridges, we no longer use anymore because they really don't have that many ports. They don't have the functionality, because that is the main purpose of a switch, is functionality. Bridges were meant just to segment, where switches, which is what everybody uses today, is because of its functionality, all the things that it brings into the network. Okay, we have wide area network protocols like PPP, frame relay, wireless, and you do have two sublayers, the MAC and LLC, logical link control. This is the 802 IEEE standards, and the 802.2, which more specifically for the LLC. All right, and then we go into the physical. Here's when it's coming out the wire. So what's happening out here? Well, we got bits. We got zeros and ones, right? Not really. There's no zeros and ones going through the, like Sesame Street, going through the cable. Okay, it's voltage, high or low. All right, and it can go through cabling. It can go through wireless, any media, right? Satellite, water, infrared, whatever it is that you're using, that's what's going out through there. All right, hubs. We no longer use hubs, but know that hubs work there. Amplifiers, repeaters, WAN also works there, and wireless. Really, wireless is in two different layers, just like it's the wide area network stuff. Okay, so this, again, to reiterate what we just said, all right, is what you need to know. I'm giving you all the stuff that you need, that you will probably be asked on the certification. Okay, so you have the ammunition necessary, so in your brain, so when you get to your test, you jot it down before you start with what they give you, and then you begin your certification. See if I'm missing anything else here. PDUs, talk to repeater layers, blah, blah, blah. You know this. I can't reiterate enough. Let me see if I can. I'm going to highlight that with my mouse, because my finger doesn't want to do it. Okay. This is your protocol data units, data segments, packets, frames, bits. I remember it. Don't stop pouring free beer. Can't forget that. Okay. Don't stop pouring free beer. All right. That is the encapsulation order, or what is a process of encapsulation. There it is right there. Okay. And remember, encapsulation happens from layer 7. Okay. From layer 7 going down the OSI. Going down the OSI, de-encapsulation is when it reaches the destination, and it's going from layer 1 back up to layer 7. Okay? There you go. There's a lot more detail now on the OSI model. We're going to drill this to death so it is embedded in your brain and ready for your certification. See you in the next one. All right, welcome back, everyone. Now we need to understand why. Why do we need these conceptual blueprints, these layered models? Why? We have we've gone over the TCPIP model. We've gone over the OSI model. Okay, now we need to understand why. Why do we want to use this particular models? Well, better understanding of your network because you know things that happen at each layer, so it's easier to troubleshoot. So once you understand your network, it's going to be easier to troubleshoot for you because you know exactly what's going on. Troubleshooting will be isolated to a specific layer. It's either a layer 3 issue, and that's what you're going to hear out in the field. Hey, we have a layer 3 issue. We have a layer 2 issue. We have a layer 1 issue. This is the kind of things that you're going to hear about, and these are the kind of things that you're going to see, what I just said, in your certification. All right, because this is the normal things that you do. Having a background in telecommunications as well, these are the things that we tested. All right, layer 2, layer 3 issues. What was going on? And normally it's either an IP address or some command that needed to be in the router that wasn't there, or a cable that had to be plugged into a particular port in order for us to test these particular sites that wasn't plugged in. Those are the things that's when you have to send out a technician and whatever. But those are the things that why we want to use a layer model, and it's easier for vendors when they're creating any kind of equipment, any kind of protocols. All they need to do is concentrate on one particular layer. All right, not everything, because remember, way back in the day, everything was just open standards, right? So, or everybody had their particular standard just for their product. That's not, you want to what? Standardize, right? Standardization. All right, so it makes a competitive nature now. Everybody wants to go ahead and create the same things equally. It makes it better for you. So when I go buy a NIC card, all I got to worry about, okay, on the motherboard, you know, what type of NIC card I need. But when it comes to wireless, pretty much any wireless, you can connect to anything. All right, it doesn't really matter. The routers are the routers. Now the features in the iOS and things like that is a different story, but we can use Dell routers, we can use Cisco routers, we can use F5 routers, we can use Juniper routers, all these different things. The whole point is to have interoperability, right? And these why these standards have been created, all right? Not to make life easier for vendors, but life easier for us, again, when we troubleshoot a network, because understanding what happens from the moment a packet leaves your source to get to the destination, you need to understand where the problem is going to be. Did it get there? Was it unreachable? Was it timeout? Did somebody receive a partial document when you send an email? What's going on? Does it have to do with the application itself? Not the application layer, the application itself. Is there something wrong with that particular application? So all these different things help us to break down our network so we can have a better understanding of what's going on, so we can go ahead and then troubleshoot it more efficiently, right? And that's what we want, efficiency in our network engineers. All right, enough said with that. I'll see you guys in the next one. All right, welcome back. Let's go ahead and summarize what we've talked about in this particular section. Okay, now we looked at the OSI model. Pretty much we did a comparison of the OSI model to the TCPIP model. All right, but we looked at its layers. We looked at the functions that happen in each layer. We looked at the PDUs of those layers, how they talk to their peer layers on the other side, right? Source, destination. We talked about the process of encapsulation, which is don't stop, point, free beer, right? Data, segments, packets, frames, and bits. You need to remember that. And how they map over. You need to remember that as well. This is basically, when it comes to standards, it's all about memorization and the benefits. The benefits of using a layered model just making life easy for everyone, vendors and engineers, technicians, whoever that deals in the computer industry, because we need to understand where the problem may lie, especially for networking, because the layered approach, this OSI model, the TCPIP model, was created for networks, not only to give us the guidelines, the rules of how we need to create our network, but how to troubleshoot it if something were to occur. All right, this is the essence. This is the reason why it was created. All right, but with that said, we are done with this section. I will see you in the next one.